Okay, here's my two favourite examples. I will be doing this in class. So, Kitty O'Neill, oops, sorry, that's an I in there, in 1978 set the standing quarter mile record. Did a standing quarter mile, in case you're interested, that's 402 metres in 3.22 seconds. So she is the fastest standing quarter mile ever in 3.22 seconds. What was her acceleration? Her acceleration and what else do we have? Velocity, standing quarter, time was her final velocity. Was her final velocity. We should point out at this point she had the land speed record for a woman as well, and they were trying to get her the absolute land speed record. And what was her final velocity? And she was also a very famous Hollywood stunt woman. Okay, so draw a picture, dragster, woohoo! In this case it's rocket powered. Very happy driver, whee! And we'll put a wing on it so the car doesn't fly. What do we know? Well, when you're doing problems like this, there's a few things. What we're looking for when we're dealing with kinematic equations, we're looking VI, VF, A, D, T. So do we know VI, the initial velocity? And often in problems like this, it's implied. In this case, it says standing quarter mile. So if you know race car, the standing means the initial velocity is 1 metre per second. But often in kinematic problems, it will have something like you are parked at or stopped at the traffic lights, and you have to work out, or you pull up to a halt. Okay, VF is equal to, what's her final velocity? We don't know. What's her acceleration? Don't know. Distance, standing quarter mile, so quarter mile is 402 metres, and her time is 3.22 seconds. Sorry about that, I'm going to need a calculator for this problem. Okay, so we know three things, and the rules say, well, with kinematic equations, if you know three of these things, you can work out the other things. We know that there's acceleration involved because she is speeding up. So what we're going to look for is we're going to look for an equation that's got VI, D, T in it, and either VF or A. So VI, well, if it's got both of these, and if it's got VF and VA, we can't, and A, we can't use it. Well, there's VF, can't use that one. Could possibly D equals VIT plus half AT squared. You can use that one. D is equal to VI, VF, D, VI, T. We can use that one. Or VF squared is equal to. So we can use either of these two. It really is a case if you pay your money, it takes your choice. Just choose your favourite one. So D is equal to, I'm going to use this one because VIT plus half AT squared. There is a thing we have to remember here. The initial velocity is equal to 0. So in this case, VI, 0 times T, we can get rid of that. So D is equal to half AT squared. I'm a physicist, so I'm going to rearrange this first. So I'm going to rearrange this for A. So I divide both sides by by half, and T squared. Half T squared. So A is equal to D over half T squared, which is equal to, D is 402 metres divided by 0.5 times 3.22 seconds. Yes, I know a lot of squared. I know a lot of physicists will be upset about this 0.5, but so 402 divided by 0.5, which is the same as multiplying by 2, divided by 3.22 squared equals 77.54 meters per second squared. So that means she's accelerating nearly 8 gravities of acceleration. So yeah, that's pretty quick acceleration. Remember, if in doubt, go to 4 significance. In this case, you wouldn't give the actual final answer to more than 3 because there's 3 significance here, 3 here. Okay, what else? VF equals, well, want to find out velocity? We can just use this one. VF equals VI plus AT. Don't even have to rearrange it. VF equals VI plus AT. It's amazing how often you will use that equation in this, because normally you'll work out one of these and then you'll do that one because it's the easiest. VI is equal to 0 meters per second plus acceleration 77.54 meters per second time squared times 3.22 seconds equals times 3.22 equals 249.7 meters per second. If I'm being very strict, then I'll do it to 3 significant figures equals 250 meters per second. 3 SF. Okay, in reality, she actually went across a little bit slower because she accelerated a lot faster and then coasted across the line. We're assuming a constant acceleration. Okay, another example. Wait for the earthquake. Okay, another example that we can do, one of my favourite ones. Nobody died in this, but they were certainly seriously injured. A Formula 1 driver crashed into a wall, at 60 meters per second, okay, just under that, and stopped in 0.3 meters. That's how far the front of the car crumpled. Went nose first straight into a concrete wall at a racetrack. Car crumpled this much. Went from about 60 meters per second to 0.3 meters. What acceleration did they feel? Did they experience? And what time? How long did it take? Okay, draw a picture. Car, Formula 1, that crumpled nose. Whoa. Blah, blah. He's not feeling so good. Blah. Okay, so what do we know? VI equals 60, well, we want the same thing up here. VI, VF, ADT. What do we know? We know VI equals 60 meters per second. VF equals 0 meters per second. A equals, well, that's what we want to find out. D equals 0.3 meters. T, again, that's what we want to find out. So what we're going to do, choose an equation. Well, I'm going to need something, as long as it doesn't have A and T in it at the same time, we can use it. So I can't use that one. Can't use that one. I could use that one. Or I could use that one. So, you pays your monies, you takes your choice. What am I trying to find? I'm trying to find, if I do that, I'll find that. If I do it, I'll find T, or I can use this one to find A. Let's use that one. VF squared equals VI squared plus 2AD. Rearrange, so subtract VI squared from both sides. So VF squared minus VI squared equals 2AD. I want to find A, so divide both sides by 2D. So VF squared minus VI squared over 2D equals A. A equals, well, VF squared is 0 minus 60 meters per second squared over 2 times the distance, which was 0.3 meters. So we're going to go 60 squared divided by 0.6. 6,000 meters per second squared. Which, to put it bluntly, is a lot. So for a few seconds there, where they weighed 600 times their own weight. So for a few seconds there, the driver probably weighed about 42,000 kilos. So roughly the same as 6 or 7 elephants jumping on his chest. Needless to say, he didn't die, but he broke his legs in 6 places, his pelvis in 3 places, his ribs in 3 places. His heart stopped 6 times on the way to the hospital, but he did survive. Okay, what about the other one? We now know acceleration. This is minus, remember he's slowing down, minus 6,000 meters per second squared. How long did this take? Well, I can use this one. VF minus VI, equals VI plus AT, rearrange for T, minus VI, VF minus VI equals AT, divide both sides by A, T equals VF minus VI over A equals 6,000, VF is 0 minus 60 meters per second squared over 6,000, well, negative 6,000 meters per second. Because remember, this is going to be a negative number, negative 60 divided by negative 60,000. Negative 6,000. So it's going to be about 10 milliseconds. So 60 divided by, which equals 0.01 seconds, so 10 milliseconds. So this was a very short but very violent crash.